Dear students, welcome to the knowledge series. We will be talking on fuzzy alpha cut. What exactly is fuzzy alpha cut? Before that, let me discuss about the support of fuzzy set. Now, if statement over here, a membership function defined as the fuzziness in a fuzzy set irrespective of the elements in the set which are discrete or continuous. So it defines the fuzziness of in a fuzzy set. So that is the vagueness in the fuzzy set of an element that may be either a discrete or a continuous in nature. So when we define these particular membership functions, we define in terms of a fuzzy set A, that is a collection of a set of element x and its membership functions mu a of x such that x belongs to the universe of discourse. So mu a of x is called the membership of a fuzzy set A. If you look across this one, the features related to the membership functions, you will find that x is defined here with respect to x and mu x. The membership is drawn in the form of a trapezoidal shape where the core is the topmost part, support is the span of the entire membership with respect to the x coordinates, and the boundary is the inclination of the fuzzy areas. Now where the core is nothing but where the membership functions is equal to 1, boundary is nothing but where the membership lies between the 0 and the maximum value, and the support is nothing but where the membership value is greater than 0. Now under this particular case, we will see some of the features related to this particular membership. Now when we try to see these features related to the membership, the very first things let us see is area about normalized fuzzy set. Now what exactly the normalized fuzzy set it indicates? The normalized fuzzy set is that where you can try to see that it is exactly it having a two values 0, 1 and apart from that the third value is the fuzzy values. A fuzzy set where the membership functions has at least one element in the x in the universe of a discourse and whose membership value is unity. It will be having a one unity value and a 0 value, and the others are intermediate values. So that is the normalized fuzzy set. So when you go across and here when you try to see this point, that the peak point is the membership value is equal to 1. The other area when we succeed, we will see the normalized fuzzy set, subnormal fuzzy set, where the subnormal fuzzy set do not have a membership value 1. So here you can try to see the fuzzy set wherein no membership function has its value equal to 0, that is less than 1. So that means it will have a value greater than equal to 0, but it will not have a value equal to 1. So that is the case of a subnormal membership. There is a gap exit in between. Now coming to the convex fuzzy set. When we talk about a convex fuzzy set, you will be having any point you take, you will be having a two extreme boundaries. So a membership function whose membership value are strict monotonically increasing or monotonically decreasing. So that is, it is monotonically increasing and monotonically decreasing. So this is what we see in the case of a concave. So if you draw a line, it will touch this edge and this edge. So that's how you can see the case of a convex fuzzy set. Now when you go to the concave fuzzy set, you will be finding that there is a non-convex fuzzy set. You will be finding in this case the shape like this, where if you draw a line, you will be finding it will be touching the two edge. Apart from that, if it is extended, it will touch the other edge also. So that is the area with respect to the non-convex case. Now here, if you try to see the distributions, where mu a of x2 is the minimum of a mu a of x and mu a of x3. So that is what he has here. Whereas in this case, you will be mu a of x2 is given as minimum of a mu a of x1 and mu a of a of your x2 terms. So that's the range you will be finding with respect to the two edges. So that is what we see in the case of a non-convex and in the case of a convex with respect to the representation. Now crossover point we try to see here, we try to see that it is having the same like the normal fuzzy set. So in the normal fuzzy set you will be finding the same representation. Here the membership value is at the 0.5. So at the 0.5 you will be finding this shape. So here you will be finding the mu a of x is equal to 0.5. The element in the universe of discourse for a particular fuzzy set A has its value equal to 0.5. Now the fuzzy set height. So we'll see the fuzzy set height. Now when you talk about a fuzzy set, the maximum value of the membership function is a fuzzy set of a fuzzy set A is called a height of the fuzzy set. So whatever the value, now here it is a 1. Now you may be having another fuzzy set shape like we have shown here. Here suppose if this point is equal to say 0.7, so we'll treat this 0.7 as the height of the fuzzy set. Now coming to the normalized fuzzy set. A normalized fuzzy set, when we talk about, is that height of the fuzzy means maximum value of the membership functions is called the normalized fuzzy sets. So here it is a touching point, so this is a normalized fuzzy set, and it is a non-touching point, is a non-normalized fuzzy set. So that is what we termed as the case of a fuzzy set. So we convert into a point that it reaches to a 0 to 1 conditions. Now definitions of the convex fuzzy set. If you see the previous convex fuzzy set, it is being defined as a convex fuzzy set A is A of a universe of discourse X is called convex if mod of A to the power of alpha is a convex subset of X such that alpha belongs to 0, 1. That is called as the convex fuzzy set. Now here alpha cut, this is known as a alpha cut, where it is treated as if this is a fuzzy set A of a universe of discourse X. So this it is for all alpha where the value of alpha ranges between 0 to 1. So that is what it calls with respect to the fuzzy set ranging between the 0 to 1. So all the value of alpha, suppose if it is cutting alpha, so you will be taking the value with respect to these areas. So that is what mod A to the power of alpha, that is a fuzzy set to the alpha, is such that x mu a of x is greater than alpha. That is the condition. If x and mu a of x is greater than alpha, then that is known as alpha cut. Now if you take an example here, now a universe discourse X with the set of element -2, -1, 0, 1, 2, 3, 4 and a fuzzy set A with respect to this X element is defined in terms of its own membership function, which is on the numerator part for each cases. So the numerator is a fuzzy membership functions, and the denominator is nothing but a crisp fuzzy set, crisp set X. So the defined as the mod A of alpha, that is the fuzzy set alpha, is alpha cut is defined as -1, 0, 1, 2, 3 if alpha is between 0 and 0.3. So alpha is between 0 and 0.3. Anything which is having a 0 and which is having a in 0, 0 is defined, this is the nothing but the membership values. So alpha anything between 0 and 0.3. So within this range, if anything is available, those value you have to consider, and that is the set of the x. So here if you see 0.3 means -1, then 0 then you have another is that alpha ranges between and next is a value with respect to 0 case no point let us take a case 0.3 alpha 0.6. So 0.3 alpha 0.6 will be having a value how much 0 1 2. So you see 0 and 1 and 2. So under this range your alpha value is coming. And if you are taking a case with respect to 0.6 and 1, 0.6 and 1 means alpha anything between 0.6 and 1. 0.6 and 1, if you try to see 0.6 case and alpha is 1, is that you will be taking a value with respect to that one is equal to 1. And if you are taking 0 to 0.3, so 0 to 0.3 you will be having the value ranging between -1, then you are having 0, then you are having 1, and you will be having 3. And this particular this is -2. -2 is defined as. So under these particular situations you will be having the value whichever is there. -2 will be coming, -1 will be coming, then you will be having a point. So you will be having even alpha is greater than 0 and alpha is less than equal to. So you will be having 0.3 case also. So that you will be having 3. Other things you have to exclude. So 2 will not come. It is a -2 will be coming under that particular sections. So this is how the alpha cut is defined. Now to know further better, let us see here alpha cut or a alpha level set. The alpha cut of a fuzzy set A is a crisp set is defined as either you write like this A with a fuzzy represent of alpha or on the top, whichever substitute you can consider, where x says that mu A of x is greater than equal to alpha. So that is known as alpha cut alpha or alpha level set. So that is what we define. Now here if you try to see anything which is greater, so we are considering the analysis with respect to the maximum threshold values, where alpha is an arbitrary value for alpha, but it is in the range of 0 to 1. Now if you that is we consider under the case of a normal alpha cut. But when we talk about a strong alpha cut, its value is exactly represented in such a way, but it is greater than. A strong alpha cut of a fuzzy set A is a crisp defined as x comma mu A of x is greater than alpha. So you have to select between these two. So we are having a two value under the membership case. One alpha value is here, one another value is there. So alpha 1, alpha 2. So with respect to these two, you will be having the crisp set case A of alpha 1, fuzzy set A of alpha 1, fuzzy set A of alpha 2. So under this case, A alpha 1 is a subset of A alpha 2. So A alpha 1 is a subset of A alpha 2. So in this case, A alpha 1 and A alpha 2, these two is called as, is termed as nested. That is A alpha 2 contains A alpha 1, or A alpha 1 is a subset of A alpha 2. Now let's see one example here. Now if you try to see this example, consider a fuzzy set of defined by below with respect to age, that 20 comma 0.1. So what is 20 here? The x value, 0.1 is a membership value mu of x. Similarly 30.2, 40.4, 50.6, 60.7, 71, 81. So here considering the alpha cut is equal to 0.4, find the alpha cut value above old to plot the graph. So that is what we term this problem. Now here, if you try to say any value greater than alpha, so this is a normalized cut. It is not a strong cut. So under that conditions, any value greater than 0.4. So any value greater than 0.4, if you look across above, greater than above is 40 comma 0.4. So that is what we define here in this particular situations. So under this particular situation, if you try to look for, then we will be having 20 0.1, 30 0.2, 40 40 is equal to 1, 50 comma 1, 61, 71 and 81 under the particular conditions with respect to alpha is equal to 0.1. So that means if we replace this anything greater than 0.1 equal to 1 and otherwise equal to 0. So which are the things which is greater than equal to 1? So if you try to see this one, this 40 is coming, 50 is coming, and 60 is coming, 70 is coming, 80 is, but these values are less than 0.4, that's why it is equal to 0. Now another example we define, find the alpha cut for this example where old alpha or a old 0.4 is how many? So old 0. Whichever is greater than equal to alpha. So under this condition we have to consider this same 0.4. So 40, 50, 60, 70 and 80. This is coming under the condition of a old 0.4. Now the difference between and another third questions with respect to strong alpha cut, if you try to see anything greater than alpha. So in this case equal to we will eliminate. So from here this same example we remove 40, so that then the remaining becomes the strong alpha cut. So old strong. That is what we defined here. So here three things you see you define is that one case is that you replace the 0.4 with respect to 1 and 0 to define what are the categories of the two sets. Even if it is a fuzzy set, how you define another two category. And another case is that you define with respect to the given fuzzy set its alpha cut and its strong alpha cut. Third, next question we will see that alpha cut. An alpha cut of a fuzzy set is a crisp set alpha that contain all the elements of a universal set. It is given if it is greater than or equal to alpha. An alpha cut of a fuzzy set, this of is not a, is a crisp set alpha that contain all the element of a universe set, and it is greater than equal to alpha. This is a definition of the alpha we have seen in the initial case. So here x is equal to 0 to 10 given. So that is from here we are finding the number of element because this is coming under the class of fuzzy. So we are having a number of elements 0 to 10. So membership value mu of x given as x by x plus 2. Now the question is telling find the alpha cut with respect to 0.5. Now here for each element, when we put each element substitute here, so we will find the value of mu a of x. So simply we are getting mu a of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 by substituting its value under the equation x by x plus 2 for a function mu a of x. So once we get this particular range of values, now from these values we have to identify what are the elements. Now if you try to compare the x and mu a of x, remove the same and the nearest value of x, that is greater than equal to, that is the conditions. Any element greater than 0.5 we can taken into crisp value. So alpha cut in the under this particular case is what it is defined with respect to 0.5. So if you take it to 0.5, you try to see over here if we are taking a normal alpha cut, so we will take into considerations 2, 3, 4, 5, 6, 7, 8, 9, 10. So all this value. But if it is a strong alpha cut, then we have to eliminate these two. So that is what, any value greater than 0.5. So we got this membership value. So that means if suppose this is a triangle type, and if anything is greater than 0.5, that we those value we will consider, and the bottom value we eliminate. So that is the problem related to this alpha set. So based on this alpha cut, what we came to understand is that when we consider a fuzzy set having a range alpha belong to 0 to 1, under that particular situation, 0 to 1 situation, the alpha cut is nothing but it's a part of that membership functions, where x is such that the x belongs to universe of discourse such that mu of x is greater than equal to alpha. That means it will take the upper part. This is the range. If alpha is 0, then it will consider the whole value of a membership function. If alpha is here, it will take all the upper values. So based on this particular distributions, the different problem has been normally appears in the question papers with respect to alpha cut, and whenever a problem is given, it will be giving a x value, mu of x will be given, and select it to the value of alpha. You have to decide whether it will come under the group of the above levels or it is in the below level, and also under the category that whether it is a normal or whether it is a it is a strong alpha cut. So with this I conclude. Thank you.